Hello everyone. So now this is section 5.1. This one, uh, the 5.1 is about integration. The integration is also called antiderivative. Right, antiderivative. Because we will be basically the idea here is the reverse operation of the derivative of a function. So let's see. Okay, let's see. Function f of x is given. It's x squared, and if I take the derivative of this, then it will be 2x, right? So from this point to this point, we say this is a derivative or differentiation. There are different names, right? So we call this differentiation, right? From this point to this point. Now, let's say if this is given and we want to find this. So this reverse operation, from this point to this point, we call this antiderivative or anti-differentiation. All right, anti-differentiation. Oops, anti-differentiation. Okay, and this one also called, well, anti-differentiation, or this is also called integration. All right, so we'll be learning the technique to get this thing from this point. All right, so I'll be showing a technique here. All right, so okay, so now let's say, okay, indefinite integral. All right, so let's say we want to find the, or we can simply call this integral or integration. The reason we're calling indefinite integral is, well, I'll show you later. So let's say, again, let's say f of x is given. Okay, and the way we write the indefinite integral of a function f of x is this way. Like, it's not f, it looks like f, like a really big, it's like a kind of similar to f, but this is but we call this an integral, the integral of f of x. All right, so this is how we write the integral. Now and we were taking integral of f of x in terms of x, so dx. So this represents, we're taking the integral of f of x in terms of x. Okay, and these kind of when we see these kind of form, we call this indefinite integral. All right, there is another integral, definite integral. We'll be learning that later on. I think maybe section 5.4 or 5.5. So the definite integral, the way we write the definite integral is, well, there will be some number here, there will be some number here. Okay, so this one we will be learning later. So let's not worry about this one right now. Let's just focus on this one for right now. Okay, so when we see these kind of integral, as I said, this is going to be indefinite integral. And now the way we write this is, well, now we have to take the integral of this f of x, right? So when we take the integral of this f of x, well, we'll be getting some function here. So let's just say that function is a capital F of x. So this represents the integration of this f of x that is given. All right, so we'll be getting some function here. The technique I'll show you later, just in a while. Okay, so once you write the integration equation, there should be one more terms plus c. All right, when you're taking the integration or when you're taking the indefinite integral or indefinite integration of a function, then there should always be a constant at the end. Okay, so that's why I'm writing this constant plus c. So this can be any number. All right, any number, but we don't know the number, so simply we just write c. Okay, now let's see formulas. Let's see the technique of actually getting the integration of the given function. So do that in other page. So let's say, okay, we can call this formulas, or you can even call this a properties. Okay, whatever you want to say, but let's just say formulas. Okay, so the first one is, let's say we need to find the integration of x, okay, to the power n, where n is some number. Let's say, okay, there will be some, let's say x squared, x to the power 3. All right, so something like that. When you're taking the integration of something like this in terms of x, then the formula for this one will be x, okay, we have x here, x to the power, since we have n here, so when we take the integration, it will be n plus 1 on the top, or on the power, okay, x to the power n plus 1, and divide this whole thing by, again, n plus 1. All right, so this represents the integration of x to the power n. And like I said before, there should be always be a constant plus c. Okay, and we can only use this technique if n is not equals to, if n is, or basically, well, n cannot be negative. Okay, so if n is -1, we cannot use this technique. All right, so anything else except n is equals to -1, then we can use this technique. Okay, so let's say, like I said, let's say I want to take the integration of x to the power 4. Okay, I'm taking the integration of x to the power 4. Then using this technique, it will be, okay, but now we'll get x to the power, since we have 4 here, so on the top we'll get 4 plus 1, but this whole thing by, again, 4 plus 1 plus c, where c is a constant, right? So this will give x to the power 4 plus 1 is 5 over 5 plus c. Okay, and like I said, this is the reverse operation, right? Like I said, this is the reverse operation. Basically, we're taking the antiderivative, so we can check it. If so, let's say if I take the derivative of this function, I must get x to the power 4. When I take the integration of this, I'm getting this, right? But when I take now the derivative of this, I should get this x to the power 4. Let's see. Let's just check it. I mean, you don't have to do this when you do the actual problem, but let's just check it here right now to see if you're doing this correct. All right. So if I'm taking the derivative of this, x to the power 5 over 5, then we'll get this, well, I can basically just take out this 1/5, right? So just take the derivative of x to the power 5. So that will be 5 times x to the power 5 minus 1, which will give us, well, this 5 and this 5 is cancelled, right? So we just have x to the power 4, right? So that's exactly what we have here. So that means, okay, yeah, we're doing this correct. Well, you don't have to do this this checking part. I'm just showing this. Where does, like, how does this work? All right. Okay, so that's the first formula. Now the second one is, let's say if you're taking the integration of e to the power x in terms of x. All right, so as we said, the derivative of e to the power x is e to the power x. So again, if you go the reverse way, you should get the same thing. So when we take the integration of e to the power x, still e to the power x plus c always. All right, so as long as we're working with indefinite integral, there should always be this plus c, like I said, right? So yeah, just remember that. Okay, now okay, this one. Let's say I'm taking the derivative of, oh sorry, the not derivative, sorry, the integration of some number. Let's just say k this time, all right? Integration of some number in terms of x. So when you take the integration of some number in terms of x, then this will be that number k times, well, since we're taking this in terms of, well, we're taking the integration in terms of x, so there should be x here, and plus another constant. Okay, so let's say, let me show an example for this. So then let's say if I'm taking, well, using this formula, let's say taking the integration of 4 in terms of x. So integration of 4 dx, then, well, using this technique, it will be 4 times, well, since we're taking this integration in terms of x, so there should be 4x, right? And like I said, plus some constant c. All right. So yeah, this is another formula. Now, integration of 1 over x dx. So like I said, again, the integration is the inverse operation, right? So when we take the derivative of natural log of x, then we get 1 over x, right? Right, from this point to this point, we'll get 1 over x. Now let's say this is given, 1 over x is given. So we want to take the antiderivative or the integration of this, then we should get this, right? Natural log of x. So here should get natural log of x plus c, right? Now here, this x must be greater than 0. All right, so x cannot be 0. X cannot be any negative number because we cannot take the integration of a negative number. So that's what we say, x should be greater than equals to, or just greater than 0, right? Another one is, okay, let's say I'm taking the integration of some constant times some functions, all right? So this constant is multiplied with this function, okay? Then in this case, well, we can just factor out k, or we can just bring out, not, let's not say factor out. Well, we can just bring out k. So, and just take the integration of just f of x. All right. Similarly, the last one, let's say the integration of f of x plus g of x. Okay, and we're taking the integration of this again in terms of x. All right, so in this case, well, we're taking the integration of this whole thing, right? F of x plus g of x. So in this case, we can just split this into two integrations. So we can say integration of f of x in terms of x, or just dx, plus integration of g of x dx. All right, so yeah, we can split this into two parts. All right, and here it's same thing, even if there is a negative. So if there is a negative here, okay, we'll get negative here. Okay. Okay, now using these formulas, let's do some examples. Okay, so I'll do probably like 5 or 6 examples. So let's do this one first. So let's say I want to take the integration of 7 times e to the power x dx. All right, so in this case, I can now, well, this 7 is multiplied with this e to the power x, so I can basically just take out this 7 and just take the integration of e to the power x dx. So 7 times the integration of e to the power x is, like I said here, still e to the power x, right? So e to the power x, and always plus 7. Sorry, always plus constant. Let's say 4 times. Okay, now instead of x, now I'm using t. Doesn't matter. It's a variable, right? So let's say t to the power 8. Now here I have to say d, not x, because since we have t here, so there must be dt. All right, so now we're taking the integration of this function in terms of t, right? So again, this 4 is multiplied with this t to the power 8, so this is just a number. So since these two are multiplying, so I can take out this 4 from this integration. So 4 times integration of t to the power 8 dt, right? So the integration of just this is, well, still have this 4, so 4 times the integration of this is t to the power 8 plus 1 over, oops, that's 8 plus 1, right? Yeah, there should be plus c, or plus constant, right? So now after this is equals to 4 times t to the power 9 over 9 plus c. All right, so this technique is, well, this formula, right? I just use this formula. So this one is similar to this example I showed. It's just that now instead of x, I have t here. Okay, now let's say I want to take the integration of this whole thing, 5x to the power 4 plus 2x minus 7 dx. All right, so now here we have a plus here we have a minus here. So this one is similar to this last thing. So first I can split this into, since we have 3 terms here, so I can split this into 3 parts, right? So I can also write this as like this. So integration of just this 5x to the power 4 dx, right? Plus, so plus integration of 2x dx minus integration of 1 dx. All right, so now again, I can just take the integration of now just this part. So again, this 5 is multiplied with this x to the power 4. So I can just factor out this 5 and just take the integration of this one. So x to the power 4 plus 1 over 4 plus 1, right? So again, I'm using this formula, right? Okay, there must be plus c, right? Once we take the, but since we're taking well, let's write it. I mean, it doesn't matter. So plus c. Plus, now let's take the integration of this part. So I can factor out, or I can bring this to out here. So we're just taking now the integration of just x. So x to the power, well, that is 1, right? So 1 plus 1 over 1 plus 1 plus another constant. So just to make these two different, because there are going to be two constant, right? So let's just write this c1, c2, right? Minus the integration of just the number is, if you take the integration of just the number, just some constant, then there will be that number times x, right? And plus another constant. So since we're taking the integration of this one, so 1 times x will be just x, and plus constant. Again, let's write this c3. So these are just constant number, right? So we don't know that number, but there is a constant, some number. So as we don't know what number are these, so when we add all of these, we still don't know what exactly those are going to be, right? C1 plus C2 plus C3 can be, again, another number. So let's just say that number is C. Okay, so when we take the integration of something like this, so you don't have to write C1, C2, C3 every time. You don't have to write constant every time. As long as you write plus C at the end, that will be enough. But you have to write plus C at the end, all right? So you don't have to write this every time, okay? So anyway, this will be 5 times x to the power 5 over 5 plus, well, yeah, I'm just gonna multiply 8 all of these, so I'll just write C at the end. Now again here, well, here, this 5 and this 5 will cancel, right? So I don't have to write that. So it will be just x to the power 5 here. Again, this 2 and 1 plus 1 is 2, so that's canceled. So x squared minus x, right? And so when we add all of these constant, plus c. So as long as you write just plus c at the end, it should be enough. So like I said, you don't have to write C1, C2, C3. Okay, just to save your time. Okay, now let's do another one. Let's take the integration of 5 over x minus 4 times e to the power x dx. So here, again, I can split this into two parts. So integration of 5 over x dx minus integration of 4 times e to the power x dx. So here, again, this 5 is multiplied to this 1 over x, right? So I can basically take this out. So I'll just get 5 times 1 over x dx minus similar thing with this one. I can take out 4, so I'll just get integration of e to the power x dx, right? So now the integration of 1 over x is natural log of x, right? So 5 times natural log of x minus and 4 times e to the power x, because the integration of e to the power x is still e to the power x, right? And like I said, at the end, you can just write plus some constant. Okay. The integration of, let's say, x to the power 4 minus 4 over x to the power 3. Okay, so here, when you take the integration of this one here, well, so dx as well. So please don't do this. Don't just like it's not equals to the integration of this. So maybe some of you guys might just write it like the integration of x to the power 4 dx minus integration of 4 dx over integration of x to the power 3 dx. No, you cannot use that property here. The only time you can use that property is like I showed here. Now x of 5 over x minus 4 times e to the power x. So there is a minus here in the middle, so I can just split this into 2 parts, something like this. But here with this division sign, you cannot use this idea. This is completely wrong. All right, so when you show this on your first step, you'll get 0 points because you started wrong, right? Because you just started wrong, so there is no way you are going to get the right answer at the end. Maybe sometimes you might get a right answer just depending on what problems I ask, but the process you're following is completely wrong. So you won't get the right answer. Okay, so this is wrong. So here we can, well, since we're taking the integration, so we are not using any product or quotient rule here. All right, we're not taking derivative, we're taking integration. So now for this one, well, this is wrong. So let's just erase this part. Okay, so here, what we can do here is, well, now I can, well, since there is a minus here, let's just split this into, again, or let's just split this equation like this. So x to the power 4 over x to the power 3 minus 4 over x to the power 3 dx, right? I can do this, right? So these two are exactly the same thing, because now when I combine these two, well, since this has the same denominator, so you'll get this, right? So I can do this. Now after this, well, we have this minus here in the middle with 2 terms, so now I can use just this technique I did here. So I can basically now say x to the power 4 over x to the power 3 dx minus integration of, well, now I can move this x to the power 3 to the top or to the numerator. So this will give 4x to the power negative 3 dx, right? I can do this. Now, well, x to the power 4 over x to the power 3 is, I can just write this, just x, right? So now after this, when we take the integration, of this just x, it will be x to the power, well, since there is a 1 on the top, so 1 plus 1 over 1 plus 1, right? Minus, I can bring this 4 outside and just take the integration of x to the power -3. So when you take the integration of x to the power -3, so x to the power, well, now we have a negative number that's -3, right? -3 plus 1, right? Using this, whatever number we have on the power, that number plus 1, right? Plus 1 divided by, it's the same thing, right? So -3 plus 1, divide this by, again, -3 plus 1, right? And of course, plus constant. Okay, so now let me just do it here. I have some space here. So from here after this, okay, so now after this, it will be x to the power 2 over 2 minus 4. This will be x to the power -2 over -2, right? 3 minus -3 plus 1 is -2. But this negative and this negative will make, well, this will be gone. So this one will be positive, right? Okay, and plus constant. Now, well, 4 over 2 is 2. I can now move this to the denominator, which will make this x to the power -2 will be x to the power +2. So x squared over 2 plus this is just 2. And if you move this to the down or to the denominator, it will be x to the power +2 plus c. Okay. Okay, let me assign you this thing. So let's say you want to take the integration of x times x squared minus 2 dx. So how do you take the integration of this? All right, so this is a quiz problem, all right? So do this as a quiz. So the idea, well, I'm just gonna explain to you. Before you started taking the integration, first distribute this x to these two, right? And then after that, you can take the integration, right? So here, okay, let me just show you that part. So x, when you distribute this, it will be x to the power 3 minus 2x. All right, there you go. So now this one is similar to this case, right? Now just take the integration of x to the power 3, take the integration of this 2x, there is a minus in the middle. All right, so yeah, this is a quiz problem. So make sure whenever you do this problem, write this whole thing and then complete your answer. All right, so this is the quiz problem. Okay, so I think that's it for this lecture. Yeah, I'll see you in the next video. All right, thank you.